Good evening and welcome to Rudy's Electronics Lab. This evening a bit of a different episode. Today I got very annoyed by my headphones failing on me. And by my headphones I mean these Etymotic ER4 series. This is the ER4XR extended range, the latest version. I first heard about these headphones maybe some 15 years ago when they were described somewhere as a wire directly attached to the brain. And I was triggered on that, I admit. I got myself a pair and I've been super happy with them since then. If you haven't ever tried Etymotics, then I would say go ahead. It's an in-ears headphone of the earlier generation with a single driver type of design. Although they do make dual drivers now, or multiple drivers. Anyway, they are fairly delicate, so this is not my first one. I had already a couple of ones over time, but well, 50 years is a long time, I would say. But this is the first time they're failing me on this way. One of them sounds distorted to me. So I thought this is a good little test to run here because we got a couple of oscilloscopes and can do spectrum analysis. So let's try to see if we can actually see that the headphone is going wrong. How I'm going to do that, I've got one earplug here, the good one, connected to a small condenser microphone, a REL lavalier microphone. Rode from Australia, connected to a MixPray mic preamp with phantom power. I'm going to run it in a safe zone in which it's not going to distort, and we're going to look at the signal on the both oscilloscopes. And as for the headphone, I'm going to feed it with a sine wave of 440 Hz I got ready here. Yeah, so on both scopes we can see the sine wave coming in. There's a fair amount of noise here. It's me talking, there is the various devices in the lab making noise, and the output level of this earphone is very low. It's supposed to be, it's in ear, it's right into your ear, so we got to be very careful here. But I'll be quiet in a moment so we can do the analysis. I got the signal on both scopes here, but of course we want to go and move to the FFT analysis to see if we can anything specific with this set of headphones. Let's go ahead and we'll start with the Roden and Swartz FFT mode. Yeah, so it's taken in a moment. Yeah, and I'm talking at the same time. It's taken a moment, but we do see some tones coming in. In a moment I'll be quiet so we see what we do. I'm looking here from 0 to 10 kilohertz, so the lower part of the audio range. Resolution bandwidth of 8 Hz, so it's pretty detailed what we're gonna look at, and so it's taking the time. Obviously, that's the way it goes with FFT. So let's see for a moment. And okay, I'm now on. I see the signal, but maybe I should look at the averages. So I'm going here to the to averages. I probably want to look at 8 averages. Let me see where I'm going to set 8 averages. Yes, there we go. And let's give it a moment. Okay, I stopped it here. I'm a bit impatient. I waited 5 averages, I think, but already can see the tones coming in. We got a fundamental tone here, and we got a couple of higher tones. Let's take a quick look what the higher tones are. I'm going to get my cursor. My cursor source got to be the FFT measurement, and should be able to. Whoops, FFT average. Should be able to go around. So the fundamental source. 441 Hz, yes, that's what we should expect. And the first fundamental is 1.3 kilohertz. So that's 3 times the fundamental. So we got the third harmonic. Next one is 2.2 kilohertz, so that must be the fifth harmonic. So what we're getting is uneven harmonics, so that seemed to work pretty well. Let's also now move to the next scope here, and that's the signalant. We've done a number of comparisons here. I'm going to put the MET function on. Okay, I'm going to hold it here. Yeah, we got the MET function on, FFT. We got also 8 averages, and we're getting the same type of signal. He only shows it to 0 here from the middle on. Of course, I can move that a little bit along on the scale. So what I like about the signalant is actually we go and get all the values in a peak list. That's something that the Roden and Schwarz doesn't have. The frequency measure actually is a little bit off. It's off by 10 Hz, but I still see the third and the fifth harmonics. The other thing that I really like about the Siglent here is that compared to the Roden and Schwarz, I can actually set the time base in the way that I want and keep the time base when I'm into the FFT analysis. With the Roden and Schwarz, earlier it was another time base, but now the time base, I can just show the time base which is used for the time it takes to take the whole sample, and I cannot zoom that in or anything, so I cannot visually inspect the waveform. And this can be kind of relevant, because now if I keep a bit quiet, we'll see got a perfect, got a sine wave here. And I think if we're going to put the other one in, we're actually going to see it's not a very good sine wave. Okay, let's go with the wrong one. Okay, now I've put the wrong headphones in here, and if you already inspect the signal here, we'll see it's not so much a sine anymore, but we see distortion. Yeah, alone by this distortion we can already see there's something going wrong. So let's give the two scopes a chance and to gather some data. I'm going to give them both a reset on the sweep, and we're going to look at what they're going to show us. Yeah, the picture is clear. I see much more distortion here, and I see again the uneven harmonics. We see them here back in the table, but I also see a higher amount of even harmonics, and that's probably even what I hear quite a bit more. So yes, unfortunately we got a broken headphone, and I already tried to replace the filters. You got couple of filters in these things that you can be exchanging manually. There's not that's not the reason. So I'm afraid I'm really stuck with a broken driver here. Too bad. I love them. I'm going to order a new one. Should keep one on spare. But this is something not to be repaired. But at least we can see clearly with our device what's going on. Reflecting on how the both scopes are doing. I think in some way I kind of prefer, the detail that we can get here, and actually we can even here get to a crazy resolution bandwidth of lower than 1 Hz. Let's give it a second. Yeah, so that's very nice. We'll need to wait a moment for all the averages to come out here with all the noise in the lab. But definitely I do like on the Siglent that I can get the analog time base, the X time base exactly how I want it, and I get the peak list, which is very convenient to be looking at. Okay, that was a short video for today. Hope you like it, and see you next time with a more elaborated video, I think, on measurement equipment.